Okay, for those of you that left early or were absent on Friday, April 13th, this is the activity that we did that will help you with the homework that you have or had to do. So the activity was called Limiting and Excess Reactants. And you should know by now that reactants are the things in a reaction that react with each other and produce products. So in this activity, the first thing we looked at was assembling a car. And just based on the picture, how many of each part are needed to complete one race car? So these are the parts. And this is the race car. So you should see that there is one body, 1, 2, 3 cylinders, one engine, and 1, 2, 3, 4 tires. Now we'd have to ask ourselves how many of each part would be needed to construct 3 complete race cars. Well, I know that one body is needed for one car. So if I need 3 cars, that means I need 3 bodies. And since there are 3 cylinders for one car, and I need 3 cars, that means I need 9 cylinders. I would need 3 engines. I would need 12 tires. Those should all be things that come easy for you. Well, what if we had hundreds of tires and hundreds of car bodies, but we only had 5 engines and 12 cylinders? How many actual complete cars could we build? So I have 5 engines. And I know in my car that 1 engine is enough for 1 car. In that case, I could get 5 cars. If I have 12 cylinders, I know that I need 3 cylinders for 1 car, which means I could only get 4 cars. So even though I have enough engines to make 5 cars, I only have enough cylinders to make 4 cars. Once I make 4 cars, that's it. That's the maximum amount of cars that I can build, because at that point I have no more cylinders. That means that the cylinders limit the number of cars that I can make. You could almost look at it like a reaction. We have 1 body, 3 cylinders, 4 tires, 1 engine, and that gives us 1 car. So if we look at these different scenarios, so I have a container A that has 3 bodies, 10 cylinders, 9 tires, and 2 engines, the maximum number of cars completed would be 2. So if I look at the bodies, I have 3 bodies, and I need 1 body for 1 car. That gives us 3 cars. And you do that for each one of these. 10 cylinders, 3 cylinders per 1 car, that gives us 3 cars plus an extra cylinder. 9 tires, 4 tires per 1 car, that gives us 2 cars with 1 extra tire left over. And then we have 2 engines, 1 engine per 1 car would give us 2 cars. So in this case, the maximum number again would be 2, and the limiting part would be engines. Once I make those 2 cars, I can't make any more cars. I have no more engines. So go ahead and try and go through B, C, D, and E and see if you can determine the maximum number of completed cars and what part is limiting. If you pause the video now, you can do that on your own. I'll show you the answers in a few seconds or minutes. But for real, pause the video. Alright, so if I have 50 bodies, 12 cylinders, 50 cars, 5 engines, go through that process and you can determine that you can only make 4 cars. And the limiting part is going to be the cylinders. I only have 12 cylinders. I need 3 cylinders for 1 car. So we always have to use this ratio that we find in this reaction. Alright, looking at container C, the maximum number of cars we can also get is 4, except this time our limiting part is the tires. 16 tires, I need 4 tires for each car, so that means I can only get 4 cars. Container D is 3 cars, or the maximum amount of cars that I can complete, and the limiting part would be the cylinders. I only have 9 cylinders. Container E, I could get 10 cars, and the limiting part would be the tires. This same process, this same idea can actually be used for chemical reactions. So hopefully you should know by now that the coefficients in a balanced chemical reaction tell you how many moles are used and are produced. So for example, in this one we have 2 moles of water react with 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. And if we look at the different ratios that we have in this chemical reaction, we have 3 ratios. 2 moles of hydrogen, 1 mole of oxygen, 2 moles of hydrogen, 2 moles of water, and then 1 mole of oxygen to 2 moles of water. So these are the different ratios that we have in this balanced chemical equation, and I can use them to determine how much product or how much reactants I need depending on what I have. So for example, let's say I have a limited amount of hydrogen. Let's say I only have let's say 4 moles of hydrogen. And I want to know, if I have 4 moles of hydrogen, how much water can I get? So what I have to look at is the ratio between moles of hydrogen and moles of water, since that's what I'm given and that's what I'm looking for. And that ratio I get in the balanced chemical equation. 2 moles of hydrogen will give me 2 moles of water. Moles of hydrogen would cancel out. You multiply across and divide by the bottom. 4 times 2 is 8, divided by 2 is 4. So if I have 4 moles of hydrogen, I can get 4 moles of water. Let's say I also have 4 moles of oxygen. How much water could I get then? So if I have 4 moles of oxygen, how much water could I get then? Well, now I need to use a different ratio. I need to use the ratio between oxygen and water. In that ratio, I have 1 mole of oxygen will give me 2 moles of water. Just like before, the units on the top and the units on the bottom must match so they can cancel out. Multiply across, divide by the bottom. 4 times 2 is 8, divided by 1 is 8. So if I only have 1 mole of oxygen, I'm able to get 2 moles of water. So in that case, if I have 4 moles of oxygen, I'm able to get 8 moles of water. This process is what's called stoichiometry, which we'll talk about more later. But stoichiometry is basically looking at the quantity of chemical reactions. How much product or how much reactant do we have or do we need? Hopefully this helps you in your homework.